We'll be looking at ODE. Okay, let me first of all give a brief introduction to first. We're looking at first order ODE now. Now, a first order ODE involves the derivative of y or another dependent variable with respect to x. It mustn't be y actually, and it mustn't be x. It can be t and y. It can be s and t. So what you need to know is that y is the dependent variable and then s the independent variable. So it says it involves the derivative of y or another dependent variable with respect to x. And the highest derivative is first order. You get? So whenever you have first order, that's first order, the y, the s, it's not the 2y, the s square. Then we call it first order ODE. If it is the twice derivative, that means you differentiate twice, then it would have been second order, but this is first order. Now, having said this, I can have this as s and t. I can have this as u and t. Now look at this. If this is s and this is t, automatically s becomes the dependent variable and t becomes the independent variable, telling you that, or telling us that s depends on t for its value. Just like saying y equals to s plus something. To get your y, you must put something in your s to get your y. So it can be s equals to t plus something. To get your s, you must put your t to get your what? Your x. So don't think that it's always the y, the s, so that you will not be confused when you see it. Now, we have types of ODE. We have the separable ODE. Separable ODE in this form, where you can easily separate your s function from your y function. Then we have the linear equations, where you have plus or minus sign in the function. You get, not necessarily plus or minus sign, but you cannot really separate it as this one, because even within this function g and h, you can also have plus and minus and can be separated. But this one now, if you have even plus within this function or whatever, it can't be separated as a thing. So now moving forward, we have also exact equations, but our major focus in this one now we're doing is actually this one. This is our major focus, the separable one. That's the major focus. So we have examples here. Example 1 deals with the separable one. It's a very, very simple one, just for introduction's sake. So this is the question you are given. You have to solve it using the separable method, because s and y, I can easily take s to meet y, x, and then take y to meet y. It's simple. What do I do first? Step 1, say rearrange. That's separating the variables now. Want to rearrange so that each variable will be with its own neighbor. First of all, what you're going to do, divide both sides by y. If you do that, you have the y over the s over y the s. If you divide both sides by y now, this thing now, you have y and the y over y the s. Then when the s meets the other side, you have s the s. Yeah, just do anything you can do. Number mathematically the same. Make sure that the y and y are together, and then your s and the s are together. That's just what is done here. So you are going to integrate both sides now. You integrate here and integrate this other side separately. This with respect to y and this with respect to what? To x. If you integrate this 1 over y from mathematical standpoint, you are going to have ln y equals to x is raised to the power 1, add 1 to the power 2 divided by 2. You have x squared over 2. Then you must add a constant this side. The constant is not added to this side though. It is added to this side. Please take notes. Now we have done this. The next thing, we want to make sure that y is the solution of the formula. We want to ensure that y is the solution of the formula. So you can just do this. Take the exponential of this side, exponential of this side. If you take the exponential of this side, ln will cancel. You have just y left. You get exponential of x squared over 2 will be this plus exponential c. So this thing is not supposed to give you this yet. Let me just explain what happened there. This exponential s squared over 2 plus exponential. Okay, sorry for that. This is a mistake actually. Sorry. The exponential will carry this, and then lane will cancel. The exponential will carry everything here. So you have exponential s squared over 2 plus c. That's what you will have here. So you can also, when you are done with that, you know that if you say exponential something plus something on the power, you can just take it as exponential, the first one, times exponential, the second one. Both of them are, that's correct mathematically. So as far as they have the same base, it's correct. So if you are doing it in this case now, it will be exponential this one times exponential c. And the exponential c is just something as a constant of its own. So you can just put it as another c again, or you can leave it the way you have done it before. It's still correct that way. That's exponential s squared over 2 plus c, which is the safest way to do so. So the whole of this will be on the power. That's what I'm trying to say. So you can leave your answer at that point instead of leaving it this way. It's still okay.